Okay, on example 3 here, we're going to practice evaluating these expressions without a calculator. And so let me just be very clear in what this question in letter A is asking when I say log base 5 of 125. I am saying what power of 5 equals 125? Or another way to say it is 5 to the what power is equal to 125. And so you may know that just immediately, that 5 to the third power is equal to 125, and therefore the answer to letter A is 3. And you may not know that right offhand. And so if you don't know that just automatically, here's my suggestion to you. Set this equal to x and put it in exponential notation. And so that means I'm going to use the log loop and write this as 5 to the x is equal to 125. And then work on getting this to be in the same base on both sides. And so the same common base here would be 5, and you would just have to do some guessing and checking to figure out that 5 to the third is the same as 125. And now that those bases are the same, you can cancel them out and notice that the exponents will have to equal. And so therefore, x is going to equal to 3, and so this expression up here is equal to 3. Okay, letter B, log base 7 of 1 is equal to what? So again, this question is asking 7 to the what power is equal to 1, or what power of 7 is equal to 1? Well, here's a beginner's tip. Anytime this number right here is a 1, the answer has to be 0. Because that's the only thing that you're going to be able to put in the exponent in order to get a 1. And it will not matter what the base is here, okay? Because anything raised to the 0 power is equal to 1. Okay, letter C, this is saying log base 1/3 of 81. So again, what does this really mean? 1/3 raised to the what power is 81. And that's probably not one that you know just right off the top of your head, so I'm going to suggest setting this equal to x and putting it into exponential notation. So 1/3 to the x is equal to 81. Okay, the common base that we want to get in on both sides is 3, and so this is going to be 3 to the -1 because it's a reciprocal right now. And so to make it not a reciprocal, I'm going to put a negative in the exponent, and so that'll be 3 to the -x is equal to 3 to what power is 81? Well, 3 to the second is 9, 3 to the third is 27. If you multiply by 3 one more time, you're going to get 81, and so that would be 3 to the fourth. Now that those bases are the same, you can cancel them and set their exponents equal, and so x is going to equal to -4, which means the answer to this expression is -4. Okay, letter D, log base 8 of the square root of 2. So again, I would suggest putting this equal to x and then rewriting it as 8 to the x is equal to the square root of 2. Now, when we talk about square roots, there is an algebra trick, or not a trick, but a property that we use, and here is the property, that when we have a to the m over n, this is the same thing as the nth root of a to the m power. And so for this square root, whenever we have the square root of x, let's say, that is always equal to x to the 1/2 power. And so when I rewrite this in base 2, I know that 8 is 2 to the third power, since 2 times 2 times 2 is equal to 8. And so that part can be rewritten as 2 to the 3x, and that's going to equal to 2 to the 1/2 power, because square root of 2 is the same as 2 to the 1/2. Okay, so that's going to give me 3x is equal to 1/2, and if I divide both sides by 3, that's going to give me x is equal to 1 divided by 6. And so 1 divided by 6 is going to be the answer there. If you're struggling there with the fractions, notice that dividing by 3 is the same as multiplying by 1/3, and then 1/2 times 1/3, you just multiply across, and so that's how I got 1/6. Okay, for log base 36 of 6, if I set this equal to x, then this is going to be 36 raised to the x is equal to 6. The common base here is going to be 6 because 6 to the second is 36, and this is 6 to the 1 over here, and so therefore this is going to say 2x is equal to 1, and divide both sides by 2 in order to get 1/2. And that should make sense that the answer there is 1/2, because if you think about it, this question is asking 36 to the what power is 6, and since 6 is the square root of 36, then it means that I would have to raise 36 to the 1/2 power, because that would be taking the square root in order to get 6. Now, letter F does not have a number to indicate the base, and so remember from the previous notes that means that this is base 10. And so this is going to say 10 to the x is equal to 0.01, which is really just another way of saying 1 over 100, which is really just another way of saying 1 over 10 squared, which is really just another way of saying 10 to the negative 2 power, so that I can move that up to the numerator and actually have like bases. And so now the bases are the same, therefore I'm going to set the exponents equal to each other, and I get that x is equal to negative 2, which means that that expression is equal to negative 2. Okay, couple of more examples here just to give us a little bit more practice. So again, here on letter G, I'm going to write 1 over 64 to the x is equal to 32. Now that 1 over 64, the 64 is in the denominator. I want it to be in the numerator, which means I'm going to have a negative go on my exponent. And I also need to think about what the like base needs to be. And so the like base here is going to be 2, because I know that 32 is 2 to the 5th, and 2 to the 6th is 64. So I'm just going to kind of go slow here and rewrite 64 as 2 to the 6th. And then this can become 2 to the negative 6 raised to the x, which is equal to 2 to the 5th. And then that really just becomes 2 to the negative 6x is equal to 2 to the 5th. Because whenever I have a power to a power, what I end up doing is I multiply those powers together. And so now I'm ready to drop the bases. So negative 6x is equal to 5. And so therefore x is equal to negative 5 divided by 6. Okay, letter H, we've got something kind of similar here. So 729 raised to the x is equal to 1 over 81. The like base here is going to be either 3 or 9. It doesn't really matter which one of those that you choose, but 9 to the third is 729, so I could rewrite this side as 9 to the 3x, and that's going to equal to 1 over 9 squared, which is really the same thing if I move that to the numerator as 9 to the negative 2 power, which means that 3x is going to equal to negative 2, and so therefore x is going to equal to negative 2/3. Okay, and then finally, one more example here. In letter I, I've got log base a of the cube root of a to the 4th, and so that's going to bring in our exponential rule that we talked about earlier, converting between exponential and radical notation. And so I'm just going to set this equal to x like I normally would, and write a to the x is equal to a to the 4/3 power, since the exponent is the numerator and the index of the root becomes the denominator. So that becomes a to the 4/3. And so now the bases are the same. I'm ready to just drop the bases. And so x is equal to 4/3. Okay, two special logarithms that we typically talk about are base 10 and base e. The base 10 logarithm is called the Common Logarithm and is written, as we've already seen, as log. And then the logarithm with base e is called the Natural Logarithm, and it is written ln, which is log naturel, as the French would say. So it's kind of backwards. It means natural log, but it's written in a different language where the adjective comes second after the noun, and so it's the log natural or the natural log, ln. Okay, so evaluate these without a calculator. Notice that log with no base means that the base is really 10. And so this is going to say 10 to the x is equal to 10. Getting that out of radical notation means that we're going to have the exponent on the 10, which is 1, divided by the root, which is 4. And so therefore this is going to be x is equal to 1/4. Okay, and then on letter B, we've got ln of 1 over e, which is really the same thing as ln of e to the negative 1, if you want to do it that way by moving the e to the numerator and making its exponent negative. And so then what is the base of this? Well, it's base e, and so this is going to say e to the x is equal to e to the negative 1, and so x is equal to negative 1. Now, you might have known a little bit of a faster way to do that. Your Algebra 2 teacher may have taught you that natural log and e cancel out, and that's absolutely true. And so what that means is that whenever I have an expression like natural log of e to the negative 1, the natural log and the e are going to cancel, and so that's just going to leave me with the result of whatever the exponent says. And we're going to talk more about this property in the next example, and these are going to be the quote-unquote easy problems. It's just a matter of recognizing them as the easy problems. Okay, so let's look in this box at these two properties, which are consequences of the inverse properties of logarithms. And so the first one says base b raised to the exponent log base b, so notice that these bases are the same, of m is just equal to m. And so what that means is that if you have a base and then in the exponent is a log of that same base, then those two things will just cancel each other out and you'll be left with m. And then similarly, if you have log base b of b raised to the m power, the log base b of b will cancel. You'll just be left with the exponent there of m. And so I always tell students these are the easy problems. You just have to recognize them as the easy problems. And so for letter A, log base 6 of 6 raised to the third power, I notice that the 6 and the 6 are the same base. And so therefore this is just equal to that exponent, which is 3. Now in letter B, you don't have a number that's representing the base, but it's log, so that means that it's common logarithm, base 10. And so log base 10 of 10 to the 5th is just going to equal to 5, since log base 10 of 10 will cancel. Okay, for letter C, we've got e to the ln of 5, and e and ln are inverses of each other, so they cancel each other out, and it just leaves me with 5. So again, it's easy, you just have to recognize it as easy. And then finally in letter D, 8 to the log base 8 of 7. Hopefully you're catching on here and you can tell me quickly that the answer here is 7, which matches up with the argument there of that logarithm.